Alright, in this video we're going to discuss how do you graph a quadratic function. Okay, so now let's come over here and look at an example that we're in what is truly considered standard form of a quadratic equation. And in that case, we're looking at something that is y is equal to ax squared plus bx plus c. If we're looking at something in this form, the vertex is not evident from just the equation. But we can find it, and the way we find it is we find the x of the vertex first. We find the x by saying what is negative b over 2 times a. Okay. And once we have that x value, we're going to substitute it back into our equation, and that will give us our y value. So our vertex in this form will be negative b over 2a. And then the function value at negative b over 2a. Okay. All right, so that's how we're going to proceed with this one. Let's go ahead and do that. Okay, so we know when we're looking here, we're first looking for the x of our vertex. Whenever you're thinking about graphing a parabola, you're really interested in two main things at first. Where is the vertex, and does it open up or down? So let's find the x of the vertex by applying this formula. What is negative b? B is negative 4 here, so negative b is going to be positive 4. What is 2 times a? A is negative 1, so 2 times negative 1 is negative 2. This means the x of our vertex is negative 2. I'm going to find the y of my vertex by taking this negative 2, subbing it into my equation. Negative 2 squared minus 4 times negative 2 minus 4. All right, so let's go ahead and simplify this. Remember, order of operations, we need to square the negative 2 first. Negative 2 times negative 2, that's positive 4. So I've got negative 4 minus 4 times minus 2, positive 8 minus 4. Negative 4, positive 8, negative 4, I think that's 0. Okay, so our vertex is at negative 2, 0. I'm going to go ahead and put that right here as our vertex. You can also put it right here as your vertex. And let's go ahead and plot that, negative 2, 0. All right, now we're going to go ahead and go add 1, so let's see, I've got subtract 1 from x and add 1 to x, so negative 3, negative 1. Let's substitute them in, okay? Let's just do 1 since we know the trick. All right, and if I had to choose between the two, I'm going to choose negative 1. So let's do that. Negative 1 squared minus 4 times negative 1. 4. Okay, let's go ahead and simplify that. I think negative 1 squared is positive 1, so this is going to end up being negative 1, positive 4, and what do we have? Negative 4. So negative 1, positive 4, negative 4, that's equal to negative 1. We know that this will be the same because of symmetry, and we can go ahead and plot those. All right, so this is looking like we think it's supposed to look because we have the vertex. We know that it's shaped so it's going down because our a is negative. All right, so now let's go ahead and calculate our y-intercept. Y-intercepts on these functions are so easy because what do we do again? We put a 0 in for x and we solve for y. Well, if I put a 0 here and there, what happens to those terms? They just disappear, right? Because they end up being 0. So I've got 0 minus 4. Our y-intercept is 0, negative 4. And it's always going to be that way. It's always this and this will cancel out. So our c value will always be our y-intercept. Okay. Now, I can also go ahead and solve for my x-intercept, but I already have that. And notice, if the vertex is on the x-axis, how many x-intercepts will I have? I'll only have 1. Okay, so we know that that's negative 2, 0. I might think about using symmetry to get one more point over here. I'm going to draw my axis of symmetry, right? It's going to split it right in half. Then I know that if I go 2 over from that here, I can go 2 over from it here, and that will give me my 5th point, which makes it very nice and easy to graph my parabola. Okay, so I'm going to go quickly through that list, all right? What's the domain? You should kind of think about this. Domain of any quadratic. If it opens up, if it opens down. Goes infinitely left, infinitely right. Negative infinity to positive infinity. Your range will always depend on does it open up or down and what is the y of the vertex. Here, from negative infinity to 0 inclusive. Okay? What is our axis of symmetry? We drew it, but we did not identify it. The axis of symmetry is x equals -2. All right, do we have a maximum or do we have a minimum? It opens down, which means I have a maximum, okay? Maximum is, how high does it get there? 0. Where does it happen? It happens at x equals -2. Where is it increasing? Where is it decreasing? It's increasing from here over to here, so what is that interval? From negative infinity to -2. And where is the interval of decrease? From -2 to infinity. All right, last thing is, where is this function above the x-axis? Never, nunca, null symbol, okay? But where is it below the x-axis? This is a little bit tricky because it's actually below the x-axis right there. It's really resting on the x-axis there. So where is it below the x-axis? That'd be from negative infinity to -2 union -2 to infinity. Everywhere except for that point right there at -2. Okay, so we will pick up in class with some applications of graphs of quadratics, and I'll see you then.